this video, I'm going to teach you how to solve this question. So the first thing I'll do is write down my solution, and then draw the given circuit. So we have this circuit, this, the capacitor, and the voltage across input voltage, and then another resistor, capacitor 2, and this is input terminal, output terminal. So I'm going to use R1, R2, C1, C2. So I'm going to use mesh analysis for this circuit to solve this particular question. There are many other methods you can use, but I'm going to be using mesh analysis because I like using that method. So, and note that for any given circuit, if the input is drawn to be open, there is assumed to be an ideal voltage there, so it's not an open circuit. But if the output is open, like this now, that this output is open, is assumed to be open circuit, so the current flowing here is 0, which is I3. But here the current is not 0 because current I1 is not 0 because there is assumed to be an ideal voltage at the input side, but output there is no current flowing there. Is assumed to be an open circuit. So let's continue. And for mesh analysis, take this to be positive, negative, positive, negative. For mesh analysis, going through the voltage from negative to positive for mesh 1. Okay, let me write using mesh analysis. A mesh is an elementary loop, like a loop that doesn't have another loop inside. That's what it means. So for this mesh 1, from the voltage moving from negative to positive, you have that the voltage is positive minus going through any circuit component, you'll be having a negative value for the voltage drop. So voltage drop across this resistor is R1 I1, since the current in mesh 1 is I1. So I1 of t, and is a function of time. And then for capacitor, voltage drop is 1 over C integral of from 0 to t of I1 of t minus I2 of t. This is equal to 0. Since there is no other circuit component, and also know that if you are going through this mesh 1 and there's a circuit component that is common to mesh 1 and mesh 2, or let me say loop 1 and loop 2. You do the current in mesh 1 minus the current in mesh 2. But if you are going through loop 2 or mesh 2, you do the current in mesh 2 minus mesh 1. Just follow me. So this will be equal to R1 I1 of t minus, plus positive. This will be I1 of t minus I2 of t. So for mesh 2, we're going to do the same thing for mesh 2. So this will be going through the capacitor C1, which is common to, so that you see what I'm saying, which is common to mesh 1 and 2. You have a negative value, negative voltage drop. That's just how it is for mesh analysis. This will be I2 minus I1. Notice that when we're analyzing for mesh 1, it was I1 minus I2. So that's how it keeps changing. For mesh 3 to be, you also see it. So this one now that is not common to any, it's just I2 going through it. It will be minus, the voltage drop there is R2 I2 of t, and then minus, there's still another capacitor common to mesh 2 and 3. So this will give you, so this will be C1. This will be C1, C1, C1. This will be C2, 0 to t, I2 of t minus I3 of t. And all this equal to 0. So now you can leave this like this with the negative sign, or you can multiply both sides by -1, left hand side and right hand side of the equation. Now you have positive values. If you do that, so I2 of t minus I1 of t minus R2 I2 of t minus 1 over C2, 0 to t, positive, positive. So then I2 of t, I3 of t, which is equal to 0. So now let's go to mesh 3, which is the open circuit now, the main open circuit. So analyzing this third one, capacitor common to 2 and 3, you have okay, let's do this like this. Going from, for V0 of t, going from positive to negative, you have a negative value of the output voltage. We are just measuring the the voltage across is not a closed circuit. This will be minus 1 over C2. This will be I3 of t minus I2 of t, and this will be equal to dt. Sorry, it's supposed to be dt itself. This is dt equal to 0. This is also dt equal to 0. This is also dt, and this also. So let's continue. So this will equal to 0. And then making v naught of t subject, you have 1 over c2 minus, then I3 t I2 t dt, I3 minus I2 of t. So now the second thing to do is to, because we know that for the output, since this is the one that is open circuit, I3 is equal to 0. For an open circuit, you know the current flowing there is 0. So I3 is 0. So writing for equation, let's call this equation 1. 2, and equation 3. So for equation 1, it does not change since there is no I3 there, but I3 of t is equal to 0. So for 1 remains the same. I1 of t R1 plus plus 1 over C1 minus I2 of t dt is equal to 0. Or let's remove the 0. So for the second equation, it becomes I2 of t R2 plus 1 over C1 0 to t 2 of t minus I1 of t dt plus 1 over C2. So I3 now is 0. So this will be I2 of t dt, which is now the new equation 2. Now for equation 3, this becomes v naught of t is equal to 1 over c2 integral 0 to t I2 of t dt. So the next step is to take the Laplace transform. Take Laplace transform of the new equation 1, 2, and 3. So taking the Laplace transform, you will get of equation 1, Laplace transform of equation 1, you get Vi of S is equal to I1 of S R1 plus I2 S over SC1. So that's for equation 1. For equation 2, taking the Laplace transform, you have taking the Laplace transform, you have I2 of S I1 S SC1 plus I2 of S over SC2 is equal to 0. That's for the second. Then the third one, taking the Laplace transform, you have V naught of S is equal to I2 of S divided by SC2. So let's continue. From now, we are going to solve these three equations in order to get the transfer function, because that's what we are asked to find from the question. So from 3, which is equation 3, I2 of S is equal to V naught of S times SC2. From here, cross multiplying. So now we are going to substitute I2 of S into equation 2 in order to find I1 of S also in terms of the output voltage. I don't know if you understand, but let me just do it. So this is equation 2. So I'll just substitute it. I will not actually write the equation. I'll just substitute and you can check it. So V S SC2 times resistor 2 plus V naught first SC2 S1 plus V naught of S SC2 or SC2. This cancels out, equal to 0. So now let's continue. This will be V naught S expanding everything plus V naught of S, S capacitor 2, S capacitor 1 minus I1 of S minus S capacitor 1 plus V naught of S is equal to 0. This is 0. So now we can get I1 in terms of the output voltage too. So making I1 subject of the formula, move I1 to the right hand side. You can still write it like this, which will be V S capacitor 2 R2 plus this is 2 plus V naught of S. So cross multiplying, we can now get I1 of S to be V naught of S, S squared plus this is C1, capacitor 1, C1 C2 R2 plus and then plus V naught SC1. So now we can factorize from here. V naught of S is common, so this will be S squared C1 C2 R2 plus SC2 plus SC1. Now we have gotten I1 of S and I2 of S in terms of V naught of S, which is this and this. This and this. So now let's substitute the two into equation 1 to get the transfer function. Substitute I1 of S and I2 of S into 1. So if you substitute, and also because this is equation 1, this is equation 1, as we can see from here. So is equal to V naught of S times S squared C2 C1 R2 plus SC2 plus SC1 times R1, then plus V naught of S S squared C1 C2, still the same thing, plus SC2 plus SC1 minus SC2 divided by SC1. So simplifying further, this video is already getting too long. Simplifying further, this should be V, because we can see that V naught is common. V naught of S, that's output voltage, is common. So we can factorize it. This should be S squared C1 C2 R2 plus SC2 plus SC1 times R1 and plus SC2 SC1 R2. These two, this will cancel out this from here, so we'll be left with only SC1 divided by SC1. So you just have to simplify till we get the final answer. Simplifying further, this is V naught of S should be S squared C1 C2 R2 plus SC2 SC1 R1 plus S capacitor 2 resistor 2 plus 1. This is what you have since, because from here we can see that SC1 and SC1, they are common here, so you can factorize them and they will cancel out with this. So that's how we arrived at this. So this will be dividing both sides by V naught output voltage. This should be 2 S squared C1 R2 plus SC2 plus SC1 times R1 plus SC2 R2 plus 1. So now we can get the transfer function. The inverse of this will give you the transfer function. Transfer function is V naught of S over V in of S. That's output voltage over input voltage, which is 1 over 1 plus S. If you simplify everything, this is what you have. Plus R1 C2 and plus S squared C2 C1 R2 R1. So this is the solution to this question. Thank you for watching. and don't forget to like and subscribe to this channel for more videos like this.